This video we are picking up in section 4.1 again. This is that second part of section 4.1 where we do some more examples of graphs of sine and cosine. Now you can already see that it's important to understand those values of those special angles, especially our quadrantal angles for sine and cosine. That informs our graph, helps us with those 5 key points that we're graphing. We stopped with graphs of change in amplitude. So our value had a value for A that was not 1. We showed that if we have a fraction for our amplitude, for our value for A, then it is a vertical shrink or a compression. And if we have a whole number, it's a vertical stretch. So we go up and down higher from center. Now let's move on and let's talk about when we have this value B. This gives us our horizontal stretch or shrink. Now in general, the graph of a function in this form, either sine or cosine, as long as b is greater than 0, so if b is positive, is going to have a period different from 2 pi, because the period of our sine and cosine function is 2 pi over b. That value for b is going to adjust the period. So it's either going to stretch our cycle out horizontally, or it's going to compress it, shrink it back together so that I get through those 5 key points in a different period than 2 pi. Now, just to interject here, sine and cosine have period of 2 pi, allowing for adjustment by b. Their reciprocal functions do as well. Cosecant and secant also are periodic over 2 pi, with allowance for an adjustment by b. Tangent and cotangent have a different starting place for the period, but these 4 functions, sine, cosine, and their reciprocals, are periodic over 1 full rotation, 2 pi. Okay, so let's jump in and let's graph this function for sine, where we are changing the period. We are not going to graph both the parent and the transformed function, just the transformed function, which means it is imperative that you are labeling your x and y axis appropriately, throwing in some values, some coordinates for those key points. Otherwise, a sine wave is just a sine wave, and they're all going to look the same. So you've got to make sure that you show where your adjustments were made. So here, my value for A is just 1. I don't have a vertical stretch or shrink. So my peak and trough are going to be at 1 and -1. A is 1, so my range is from -1 to 1. That's not changing. What is changing is that I have this value B as 1/3. So B is going to change the period of my function. Instead of 2 pi, now it's 2 pi over 1/3, or divided by 1/3. Well, when I divide by 1/3, I have to multiply by the reciprocal. 2 pi times the reciprocal of 1/3 gives me a period of 6 pi. So to complete one cycle of this sine function, I'm going from 0 to 6 pi radians. Now we take our 6 pi and we divide that 6 pi into 4 equal intervals. That's always how I start. I take my cycle and I divide it into 4 equal intervals. What does that look like for 6 pi? If I have 6 pi divided into 4 equal intervals, 6 pi divided by 4, that will simplify. The size of my interval is 3 pi half. That gives me the size of my intervals. So as I count these intervals and I label my x-axis, I'm going 0 plus 3 pi half plus 3 pi half gets me to 6 pi half, which is 3 pi. I'm halfway there. That makes sense. So this was 6 pi half plus 3 pi half. The interval size again is 9 pi halves. Plus 3 pi halves is 12 pi halves, which is my 6 pi. So I start at 0 because I don't have a phase shift yet. and I add the interval size until I get my 5 points labeled. So I've got 0, 3 pi half, 3 pi, 9 pi half, 6 pi, because I'm adding this interval on each time. All right, and now it's just a sine wave. So we are starting, sine starts at center. Center is still at 0. Sine, positive sine, goes from center to peak, back to center, to trough, back to center, and that is one cycle. Center, peak, center, trough, center, and there is one nice sine wave cycle, one period. I could very easily extend this back the other direction and do a second cycle. It's just negative values instead of positive values on my x-axis. I'm at center, so I'm going to just keep flowing through my sine function. There is a second cycle. There's one cycle over here. One cycle, 6 pi length. One cycle, 6 pi length. Okay. If I am asked for coordinates for some of my major points, remember that you are plugging in the angle, you're getting out the function value. So at 0 radians, I'm at 0. At 3 pi half radians, I'm at the peak at 1. I'm back to center here. At 9 pi halves, I'm at the trough, -1. And at 6 pi, I'm back to center at 0. Alright, let's look at the next one. We have A is just 1. We don't have a value out in front other than 1, so my amplitude is 1. My range for my function is just -1 to 1, like the parent function. But I have a value of B as 2. When I had a fraction here, I did a stretch. It stretched it out horizontally because I'm dividing by that fraction. Now that I have a whole number, it's going to give me a horizontal shrink because I'm dividing by that value 2. Well, 2 pi divided by 2 means that it's going to complete one cycle in just pi radians instead of taking 2 pi radians, which is standard. Alright, here we go. So let's label our axes. Peak is 1, trough is -1. We are completing one cycle in pi radians, so I need to divide that into 4 equal intervals. Half of pi is pi half. Half of that is pi fourths. So I've got 1 pi fourth, 2 pi fourths, 3 pi fourths, and 4 pi fourths gives me pi. If I wanted to come down and do the interval size, I always start with the period, in this case it's pi, and divide it by 4 so that I divide it into 4 equal intervals. 1 pi fourth plus 1 pi fourth is 2 pi fourths plus a pi fourth plus a pi fourth. That's how I move from one to the other. So I've got my period of pi radians. I have my amplitude. It is positive sine function, so it starts at center. It travels through our sine wave. We're just going to do the one cycle this time. So there we go. So center is at 0, 0. Our peak is at pi fourth, 0. Back to center here. Then we got a trough down here. Oh, that's not 0. That's +1. Fix that, guys. I misspoke and I miswrote. We've got a peak at pi fourth, 1, and a trough at 3 pi fourths, -1. And then we're back to center at pi. Okay, so we can think of the graph y equals sine bx or cosine bx as a horizontal stretch of the graph when that value for b, the absolute value for b, is a fraction. When it's between 0 and 1, when it's a fraction, it's a stretch. When it's a whole number, it's a shrink, or a compression. Now this is the opposite of what it was for our amplitude, and it's because I'm dividing it out by this value of b. That's what makes the difference there. So your period for sine or cosine starts at 2 pi, but it's going to be adjusted by any value of b. So that is true for sine. That is also true for cosine. All right, let's look at our next graph example. Example number 3. We're going to graph cosine this time of 2/3 x over 2 periods. Not just one, but 2 periods. So cosine of 2/3 x over 2 periods. This is a good place to stop and remember our standard form for transformations of functions. If you go back and look at our 3rd page of notes, this is what we're working with. We've got A for amplitude, B for our horizontal stretch or shrink, our period change, C would be a change in center, D would be a phase shift. So we're still working with the value of B. This time we're working in cosine. A is just 1, so the range of this function is going to be from -1 to +1. That has not changed. Our value for B here is 2/3, so our period is going to change. Our period is going to be adjusted. Instead of 2 pi, it's 2 pi divided by that value for B, 2/3. So when I multiply by the reciprocal, I get a period of 6 pi halves, which is 3 pi. And I'm ready to set up my axes. My peak is at +1, not -1. Good grief. My peak is at 1. My trough is at -1. One cycle is 3 pi. Now I'm asked to do 2 cycles, 2 periods. I have a choice here. I could keep going to 6 pi in a positive direction, or since it's balanced at 0 radians, 0 is my starting place, it's just as easy to go backwards to -3 pi so that I've got 1 period here, 1 period here. Either way works. There's no right and wrong with that. I'm going to divide up each of my periods into 4 equal intervals. And because 3 is odd, I want to look at that interval size. So I'm going to come down here and I'm going to say, okay, I've got a period of 3 pi. I need to divide that in 4 equal intervals. That does not simplify, so that's what I've got. My first major point is at 0 radians, plus the interval 3 pi fourths, plus the interval would be 6 pi fourths, plus the interval would be 9 pi fourths, and then one more time would be 12 pi fourths. There's my 5 major points. This one will simplify, this one will simplify. So I've got 0 radians, I've got 3 pi fourths here, 6 pi fourths is 3 pi half, 9 pi fourths does not simplify, 12 pi fourth is my 3 pi, so that works, that fits. Going back in the other direction, same values, just negative. All right. Cosine. Cosine, not sine. Sine starts at center. Where does cosine start? Well, if I think about my unit circle, at 0 radians, cosine is 1. So cosine starts at peak. So I'm starting at 0 radians. My cosine function value starts at peak. It goes now center, trough, center, back to peak. When I move through the other cycle, I'm sliding through that sine wave function in the other direction. And when I draw the wave, I draw it as a wave, a smooth continuous curve. I'm not doing points, as in this is not a V, this is a curve. So I've got 1 cycle, 1 period, and 1 more. I've got a trough here at -3 pi halves, -1. I've got a peak here, 3 pi, +1. Just remember, you're inputting the angle, your output is the function value. Okay, for those who like all your steps in one place, here you go. Here's your guideline for sketching graphs of sine and cosine functions. All the steps that we've been doing in one place. So if we're graphing sine and cosine, You're going to find the period. Remember, that is 2 pi adjusted by any value for b. As long as you don't have a phase shift, we're starting at 0 on the x-axis, 0 radians, and we lay off a distance of whatever that period comes out to be. We divide that period into 4 equal intervals, 4 equal parts, and we evaluate our function for each of the 5 x values resulting from step 2. So we found our 4 intervals. Those are going to give our major points that would have been the quadrantal angles when we were on the unit circle. Those points are going to be our maximum, our minimum, and our center. So our peak, our trough, and our center. As long as our center is at 0, those center points are x-intercepts. If we have a vertical shift up or down and center moves away from the x-axis, then those center points, still center of the wave, will not be x-intercepts. We're going to do that in a minute. Plot the points, join them with a sinusoidal curve having an amplitude of whatever that value of a is, absolute value, and then I draw the graph as many periods as I need to draw it, as many cycles as I'm asked for. Okay, so there's your steps all in one spot so that you can refer to those as needed. And now we're going to put both of these things together for values for A and B. It looks like we are not getting to our phase shifts or our center shifts in this section. That's okay. Let's work through these next 2 examples, and then we're going to do some application problems. Here we have sine. We're graphing over 1 period. So you can see that I've just set it up with the assumption that we're going to be graphing in the positive direction, and we're not going to worry about going back the other way. So I've got 2 different adjustments, 2 different transformations as part of my function. Value for A is a value -3. Now 3 changes my amplitude. This negative out in front tells me it is reflected over the x-axis. The amplitude is not -3. The amplitude is 3. The value for A being negative tells me that I flipped my sine function upside down. Where typically sine starts at center and goes to peak, now sine is going to start at center and it's going to reflect over and go to trough, center to trough, and still going to flow through that wave. My amplitude is 3, so that tells me that the range of my function is going to be from -3 to +3 because center is at 0. Value for B is 2, so that's going to change the period of my function. The period 2 pi is adjusted by that value B, so the period is just pi, which means my interval size to move from one point to the next is that period divided by 4, it's just pi-fourths. So 1 period, 1 cycle, we've got a negative sine function, negative sine, don't forget to reflect it. Our amplitude is 3, so we go from +3 to -3 in our range. 1 cycle is pi radians, so from 0 to pi, I need to divide that into 4 equal intervals. 0, 1 pi-fourth, 2 pi-fourths reduces, 3 pi-fourths, and pi. Now again, if I don't label my axes, every sine function looks the same, basically. So it's essential that you go through and you label your axes here. Now we're graphing negative sine. Sine starts at center, but since it's negative, we're going to go center to trough. So my first major point's at center, my second major point is at the trough, back to center, then up to peak, and back to center. So we have a negative sine function. It's been reflected across the x-axis. Try to do a nice, smooth, continuous curve. Mine never look perfect. Yours aren't going to be perfect. It's okay. My math lab does help with that, but practice graphing by hand helps us really grasp the concept a lot better than practicing online. All right, here we go one more time. Oh, this value for B looks a little different, so that's going to change the way, it's going to change things a little bit. All right, let's see. Let's do A is 2. It's positive. We're doing cosine. Cosine starts where? Cosine starts at peak. Amplitude is going to be 2. So the range of this function is from -2 to 2 because our center is still at 0. Our value for b is pi half. That's going to change the period of my function. Period is 2 pi adjusted by b. So I'm dividing it by pi half, which gives me 2 pi times 2 over pi, because I multiply by the reciprocal when I'm dividing with fractions. That gives me 4. The pi's are going to cancel out, so the period of this function is just 4. Now, all this side work I do to organize my thinking, I don't do this just because I'm teaching. I do this because it helps me organize my thinking and back up what goes onto my graph. With written assignments, this is what I expect to see. This is what you should be doing on your paper. This isn't just what I'm doing to demonstrate to you. This is how I do the graphs. So make sure that you're including this side work as you're graphing your function. I have a period of 4 radians, but there's no pi in evidence because that divided out. I've got a nice integer value for my radians. I divide that 4 into 4 equal intervals, just like I did on all the other graphs. So I'm just counting by ones. 1 radian, 2 radians, 3 radians, 4 radians. My amplitude is 2. So peak is at 2 and trough is at -2 for my range. I'm graphing a positive cosine function. Positive cosine. Cosine starts at peak when it's positive. It would start at trough if it were negative. So I've got peak, center, trough, center, peak. There's my 5 points for one cycle, one period of my cosine function. All right, excellent. Let's go through and look at some application problems, look at some thinking problems. For example, 6 and 7. Alright, so for this, we've got 2, but I didn't have this one, I didn't have a good visual for it on the computer. I just have been drawing it by hand, so we're drawing it by hand. We're given a graph, and we're asked to come up with an equation either as cosine or sine. The thing about a periodic function is that I could write an infinite number of equations that match this, playing with phase shifts and various things. We are going to go for the most basic, the easiest version that we see. So for this first one that's already drawn for us, I see that I have a function. It's either going to be sine or cosine. We are starting at center. We have a period. Ooh, it goes to 2 pi, but how many cycles has that gone through? Let's think about this. 1, 2, 3, 4. There's my 5 points. So that is one cycle. That is going to be another cycle. So we've got 2 cycles here. One cycle, one period, is from 0 to pi. So my period is pi. What about my amplitude? Well, my amplitude is just going up and down to 1/2, so A is going to be 1/2. I'm starting at center, and it's going up, so it looks like positive sine. So let's start there. Let's say, okay, my function is going to be A positive sine B x. Now, we already said our amplitude is 1/2, so we can plug that in. What we need to figure out, what would be this value of b that gets me to a period of pi? Now, mathematically, I'm going to say, okay, well, I know that my period for sine starts as 2 pi over b. I ended up with pi. So I need to figure out what value for b is going to make this true. Since this is a proportion, I can solve it using cross products. So 2 pi equals b times pi. If I throw in a 2 as my b, that becomes a true statement. So 2 pi divided by 2 gives me just pi. That's my value for b, and there's my equation for that sine function. Okay, now let me sketch the graph for this second one that I want you to think about. You can go ahead and be sketching it as well. And we're going to start here. Alright, so this is the graph for the second one. And we're going to come up with an equation for this. I encourage you to pause the video, stop, and think about it and make sure that you understand how to come up with that equation. Now remember, I could write this in terms of sine or cosine, but I'm going to go with the most basic answer. Since it's not starting at center, it's not going to be sine. As the most basic equation for this graph, it's going to be cosine. So I've got y equals something cosine something x. Well, cosine usually starts at peak. This one started at trough, so it's not positive cosine, it's negative cosine. We've got a negative cosine function. And my trough is at -2. That's a -3 there. My trough is at -2. My peak is at +2. So this value for A is going to be 2. My amplitude is 2. That negative is what caused me to reflect across the x-axis. And then I need to figure out about the period. Now 1, 2, 3, 4, 5, this is just one cycle, one period. So what started as 2 pi over b ended up as 4 pi. I can make that 4 pi over 1 so that I can think about using this as a proportion. If I do this as a proportion, find cross products, I get 2 pi equals 4 pi b. Divide by 4 pi to solve for b. B is going to be, well, the pi's cancel out and I've got 1/2. B is 1/2. So my value for b here would be 1/2 to get me to a period or a cycle of 4 pi. All right. Now we are going to do some calculator math, basically. We're given an equation. We're told that the average temperature in Fahrenheit, degrees Fahrenheit in Phoenix, can be approximated by this function that we're given, where x is the month, and x equals 1 corresponds to January, x equals 2 would be February, etc. So basically, if x were 0, we would come up with our baseline temperature, yeah? But we're interested in the month of October. Let's just go with what we're interested in. We're interested in the month of October. Well, if 1 as x is January, that means October is going to be 10, because it's the 10th month of the year. So to find the average temperature in Phoenix in October, we're going to do f of 10 in our calculator. So we have 19 sine of pi 6 times 10 minus 4.3, and then plus 74. And like I said, this is a calculator problem. We're finding a sine function, and I've got pi 6 here, so I know that we are in radians, even though I wasn't explicitly told that as part of the problem. So when I grab my calculator to do this calculation, I need to make sure that I am in radian mode. Make sure I'm in radian mode here. I'm going to start inside. Well, 10 minus 4.3 is 5.7. I'm going to multiply that times pi 6. So times pi divided by 6. And then I need to find sine of this value. Notice that I am not rounding anything off. So I'm in radians. I'm going to find sine of, and I'm going to use my second answer combination, second answer, to bring that back that I had just found. So that's sine of that function value here. Order of operations, before I do addition, I'm going to multiply. So I'm going to multiply this times 19. And then I add the 74, plus 74. And we are going to find it to the nearest degree. Well, that's going to round to about 77 degrees. It's degrees Fahrenheit. Degree is important. It's part of my answer. So that was an equation for Phoenix, Arizona. This next equation is for Mold Bay, Canada. X is still the month, so X equals 1 is January. You are tasked with finding the average temperature in May. Well, May is going to be month 5. We're in May right now, right? So we're going to do F of 5. Notice the inside part, the sine function, still exactly the same. But because Mold Bay is in a different place, and then we've got a different kind of a baseline temperature and climate, so we have a different coefficient, and we are not adding on a constant. When you plug this into your calculator, you should come up with Mold Bay in May is just about 12 degrees Fahrenheit. I don't know where it is, but that makes me think it is very far north, right? All right, great job.